In this video, we will learn about common confusing topics in carbohydrate metabolism, that is concept of epimers, enantiomers and anomers. First one, epimers. Sugars which differ from one another only in configuration around a single carbon atom are called epimers. For example, consider glucose and mannose. Glucose and mannose are epimers with respect to C2. That means they differ only in second carbon atom. Similarly, glucose and galactose are epimers with respect to C4. That means they differ only in fourth carbon atom. The process of conversion of one epimer into another epimer is called epimerization, and it is brought about by the enzymes called epimerases in our body. Second one, optical isomers are enantiomers. According to Van Hoff's rule, the number of possible optical isomers for a given compound is given by the formula I is equal to 2 to the power of n, where n is equal to number of asymmetric carbons, I is equal to number of optical isomers. For example, consider glucose. Glucose has 4 asymmetric carbon atoms, C2, C3, C4, C5. So, it has 16 possible isomers. They are D and L forms of allose, maltose, glucose, mannose, glucose, idose, galactose and thallose. A beam of ordinary light is considered as a bundle of electromagnetic waves vibrating in all directions perpendicular to the axis of beam. When such a beam is passed through nickel prism, all vibrations except one plane is eliminated. Such a light is called plane polarized light. When a beam of plane polarized light is passed through a solution of optical isomer, and if the light is found to rotate towards right, it is described as dextrorotation and the solution is given as small d form. Optical rotation to the left side is represented as negative sign and right side is represented as positive sign. Now we will discuss about capital D and small d forms. By convention, glyceraldehyde is fixed as a reference compound based on which a sugar is designated as capital D form or a capital L form. Glyceraldehyde has one asymmetric carbon at C2, so it can exist in two forms, D-glyceraldehyde and L-glyceraldehyde. The C2 of glyceraldehyde is compared with the penultimate carbon of a given sugar. Here, penultimate carbon is a carbon which is very far away from carbonyl group and which is asymmetric. For example, if OH group at C2 of D-glyceraldehyde have the same configuration as that of C5 of a hexose towards right, that means towards right, the sugar is named as capital D form. Similarly, if C2 of L-glyceraldehyde, that means OH at left side, resembles C5 of a given sugar, then the sugar is designated as capital L form. Next one, the ring structure of glucose. There are chemical considerations and evidences to believe that in natural state, aldehyde and ketose group of hexoses exists in condensed form as hemiacetal ring, which is a result of chemical reaction between aldehyde at C1 and an alcohol group at C5. If hydrogen from C5 migrates upwards and catches the oxygen of rotating aldehyde on the same side of the ring, then it is designated as alpha D glucose. When hydrogen from C5 catches rotating aldehyde oxygen at C1 on the left side, that means opposite of the ring, then it is beta D glucose form. Isomeric alpha and beta forms of monosaccharides which differ from each other only in configuration at carbonyl carbon. That means C1 for glucose and C2 for fructose are called anomers, and the carbonyl carbon where they differ in configuration is called anomeric carbon atom.